Business Calculus 7.4. Okay, we have a graph here, and we want to find the max, the mins, the inflection points, the concavity, everything about this. So let's start off with taking a derivative. To take a derivative, we're going to need to use the quotient rule. So for the quotient rule, this will be x squared plus 1 in the denominator squared, x squared plus 1 times x squared minus 1 derivative minus x squared minus 1 times x squared plus 1 derivative. Okay, now the derivatives of this one right here will be 2x, and the derivative of this one would be 2x. So as a result of the derivative, we're going to have 2x times the x squared plus 1, which is 2x cubed plus 2x, and then 2x times x squared minus 1 times a negative gives us negative 2x cubed plus 2x. All that's still over x squared plus 1 all squared. Alright, the 2x cubes cancel out and we get 2x plus 2x, which is 4x. All over x squared plus 1 all squared. Okay, now we find the critical points. We set this function equal to 0 and solve for x. But for rational functions, we simply set the numerator, which is 4x, equal to 0, and we solve for x. So we have x is 0. So this is a critical point. Now, to know if this is a max or min, we have to put it inside the second derivative. So we're going to take this function right here and find a second derivative. Alright, so let's write this out. So it's x squared plus 1 to second power again, which is fourth power. And then we'll have x squared plus 1 squared times the 4x derivative minus the 4x times the x squared plus 1 all squared derivative. Okay. Alright, the derivative of this one right here will be 4. So that will be 4 right there. But the derivative of this one, we have to use chain rule. So this will be 2 times x squared plus 1 to the first power, then times x squared plus 1 derivative. And the x squared plus 1 derivative, all this becomes 2x. Alright, so we're going to put all that together. Alright, so on the bottom, x squared plus 1 all to the fourth power. And 4 times both 4 times this gives me 4 x squared plus 1 all squared. Okay, and this one here, I have a 2x times a 2 times a negative 4x. That gives me negative 16x squared. And what remains is this x squared plus 1. Alright, that's a lot of stuff in there. I'm going to simplify this by factoring out the x squared plus 1 out of both places here, and then canceling out with the x plus 1 down here. So here I am taking out the x squared plus 1 out of both places, and that'll leave a bracket of 4, x squared plus 1, and a minus 16x squared. Okay, and then down below we have a x squared plus 1 all to the fourth power. So one of these will cancel, and I'll do a little distributing in here. So this will become 4x squared plus 4. Alright, so these cancel, and I end up with, let's see, that'll be negative 12x squared plus 4 all over x squared plus 1 all to the fourth power. And this again is my second derivative. Now, second derivatives, when I set them equal to 0, I want to see if 0 is a max or min. So let's put 0 into this function. So putting 0 in, we'll get 0 squared times negative 12, which is 0, and we get 4. 0 squared is 0 plus 1, and then you get 1, and all that becomes 4. So that's positive. Therefore, we're dealing with a min. So 0 is a min. And that's because we have a positive value out of our second derivative. Now, inflection points. We take the numerator, which is negative 12x squared plus 4. We set that equal to 0, and we solve for x. All right, so let's subtract 4x from both sides. So we get negative 12x squared equals negative 4. Divide everything by negative 12. And we end up with x squared equals 1/3. Now when we take the square root of that, we'll get x equals the square root of 1/3, and x equals negative square root of 1/3. So we actually have two inflection points. Okay. Let's see here. And I think we have inflection points. Now the concavity, it depends on where the inflection points are. If I were, this part right here is constantly positive. This part right here is changing. So let me kind of create an equation that reflects that. Y equals negative 12x squared plus 4. This is going to be an upside down parabola and raised 4 times. So it'll look like this. And I know that it hits here at the square root of 1/3 negative, and here it hits again at the positive square root of 1/3. So I see everything down here is negative, and everything down here is negative. So I know my concave down will be from negative infinity till I get to negative square root of 1/3, and also it'll start up again on this side, which is from positive square root of 1/3 to positive infinity. That's when I'll get my concave down. Now, my concave up will be this positive piece right here. That positive piece is in between negative square root of 1/3 and positive square root of 1/3. So there's my concave up portion, my concave down portion. Let's write all these down. Let's see. Concave down, concave up. These are inflection points right here. And we have that x equals 0 is a min.